Alright, let's get right into it. Number 10. In 1852, a Scottish physicist calculated that the universe is slowly running out of usable energy, and modern physics confirms this process is not only real, but almost certainly the ultimate fate awaiting everything that currently exists. Physicist William Thomson, later known as Lord Kelvin, published research describing the universal tendency of energy to dissipate into unusable heat, laying the mathematical foundation for what is now called the heat death of the universe, a state where entropy, or disorder, reaches its absolute maximum possible value. In this scenario, every star eventually burns out, every black hole eventually evaporates, and every remaining particle spreads so thin across an ever-expanding universe that no two particles will ever interact again. Modern cosmological calculations place this state occurring roughly 10 to the 100th years into the future, an unimaginable span of time after the last light in the universe has already gone dark. There is no explosion, no violent event, no single moment anyone or anything could witness. Physicist Sean Carroll at Caltech has described heat death simply as the universe running out of interesting things to do, an ending defined not by destruction, but by the complete and total absence of anything left capable of changing, moving, or existing in any meaningful way ever again. Number 9. Physicists studying the mathematics of grand unified theories have proposed that the protons inside every atom in your body, and every atom in the universe, are not permanent at all, and given enough time, will eventually simply cease to exist. Grand unified theories, developed throughout the 1970s by physicists including Howard Georgi and Sheldon Glashow at Harvard University, predicted that protons, long assumed to be completely stable particles, should actually decay into lighter particles over extraordinarily long timescales, a direct consequence of unifying the strong, weak, and electromagnetic forces into a single theoretical framework. The Super-Kamiokande detector in Japan, a massive underground tank containing 50,000 tons of ultra-pure water, has been monitoring for signs of proton decay continuously since 1996, watching for the faint flash of light a decaying proton would produce. As of 2026, no confirmed proton decay event has ever been detected, allowing researchers to calculate a minimum proton lifetime of at least 1.6 times 10 to the 34th years, far longer than the current age of the universe. If protons do eventually decay, as many theoretical models still predict, it means that even if the universe somehow avoided every other catastrophic ending, ordinary matter itself is not permanent. Every atom making up every star, planet, and living being is running on a countdown so long it dwarfs the entire history of the universe so far. But a countdown, according to the mathematics, that may still be real. Number 8. In 2003, 3 physicists calculated a scenario in which the same mysterious force currently causing the universe to expand does not simply continue at a steady pace, but grows stronger over time until it violently tears apart every galaxy, star, and atom in existence simultaneously. Physicist Robert Caldwell, Mark Kamiokande, and Nevin Weinberg published a paper in Physical Review Letters in 2003 titled Phantom Energy, describing a scenario called the Big Rip, in which dark energy's repulsive strength increases without limit as the universe expands, rather than remaining constant as the standard cosmological model assumes. Under this model, the researchers calculated that roughly 22 billion years from now, the accelerating expansion would first tear galaxies apart, then rip solar systems away from their stars, then shred planets themselves, and in its final moments, roughly 10 to the negative 19th seconds before the end, overcome even the nuclear forces holding individual atoms together. Current observational data has not confirmed that dark energy behaves this way, and the standard cosmological model remains the leading explanation for the universe's expansion. But if Caldwell's phantom energy model is correct, the universe's ending would not be a slow fade into cold darkness, but a violent cascading destruction that dismantles the fabric of reality itself, working its way down from galaxies to atoms in a matter of minutes. Number 7. Long before scientists proposed the universe expanding forever, an older and equally serious theory suggested the opposite fate entirely, that gravity would eventually overpower expansion, pulling every galaxy back together into a single point in a mirror image of the Big Bang. The Big Crunch model, developed through general relativity calculations following Einstein's 1915 field equations and explored extensively by cosmologists through the mid-20th century, proposed that if the universe contains enough total mass, gravity would eventually halt cosmic expansion and reverse it, causing all matter to collapse back into an extremely dense, hot state, resembling the conditions of the Big Bang. This theory lost significant support following the landmark 1998 discovery by astronomers Saul Perlmutter, Brian Schmidt, and Adam Rees, who won the 2011 Nobel Prize in Physics for confirming the universe's expansion is actually accelerating, not slowing down, as a future collapse would require, based on precise measurements of distant supernovae. However, some theoretical physicists, including researchers exploring modified dark energy models, have not entirely ruled out scenarios where dark energy's strength could eventually decrease or reverse sign in the distant future, potentially reviving a Big Crunch scenario. If this occurred, everything currently expanding apart would one day begin rushing back together, ending not in cold emptiness, but in a final, all-consuming collapse, mirroring the very beginning of everything. Number 6. In 1980, two physicists proposed that the empty space surrounding you right now might not be as stable as it appears, and if a random quantum fluctuation ever triggers a specific kind of collapse, the destruction would spread outward at the speed of light, with absolutely no warning. Physicists Sidney Coleman and Frank DeLucia published a paper in Physical Review D in 1980, formally describing vacuum decay, the theoretical possibility that our universe exists in a false vacuum, a temporarily stable low-energy state that is not actually the lowest energy configuration physically possible for space itself to occupy. If a quantum fluctuation anywhere in the universe ever triggers a transition to the true, lower-energy vacuum state, a bubble of new physical law would begin expanding outward at light speed, converting the laws of physics inside it into something completely incompatible with atoms, chemistry, or anything resembling the universe we currently understand. Following the 2012 discovery of the Higgs boson at CERN, physicists including Joseph Leakin at Fermilab calculated that the particle's measured mass, approximately 125 billion electron volts, places our universe uncomfortably close to the exact boundary of this kind of instability. Because the resulting bubble would expand at the speed of light, no signal or warning could ever precede it, meaning this specific ending, unlike almost every other theory on this list, could already be happening somewhere in the universe at this exact moment, silently expanding toward us. Number 5. Physicists have calculated that the universe's ability to create new stars is not permanent, and that we are currently living inside a narrow, temporary window of cosmic history that will eventually end, leaving behind a universe with no new light being born anywhere at all. Astrophysicists Fred Adams at the University of Michigan and Gregory Laughlin at the University of California, Santa Cruz published extensive research beginning in 1997, later expanded into their book The 5 Ages of the Universe, dividing cosmic history into distinct eras based on the availability of star-forming material. Their calculations place us currently inside what they call the Stelliferous era, the period during which stars actively form from available hydrogen gas, an era they estimate will end somewhere between 10 trillion and 100 trillion years from now, once the universe's usable star-forming gas is finally exhausted completely. Following this, Adams and Laughlin described the degenerate era, in which the universe contains only the cooling remnants of dead stars, white dwarfs, neutron stars, and black holes, slowly fading as they exhaust their own residual heat. It means the universe we currently observe, filled with bright, actively forming stars and galaxies, represents only a brief, early chapter in an overwhelmingly longer story, one that spends the vast majority of its existence in progressively darker, colder, and quieter states long after our own era has ended. Number 4. Physicist Stephen Hawking proved in the 1970s that even black holes, often considered the most permanent and destructive objects in the universe, are not actually eternal, and are instead slowly evaporating, meaning that even the darkest, densest structures in existence are secretly on a countdown toward their own disappearance. Stephen Hawking, working at Cambridge University, published groundbreaking research in 1974 and 1975 demonstrating that black holes emit a faint form of radiation, now called Hawking radiation, caused by quantum effects occurring at their event horizons, which very slowly causes them to lose mass and energy over unimaginably long timescales. Calculations based on Hawking's work indicate that a black hole with the mass of our Sun would take approximately 10 to the 67th years to fully evaporate, while the largest supermassive black holes, sitting at the centers of galaxies, could take as long as 10 to the 100th years, the same almost incomprehensible timescale associated with the universe's eventual heat death. This means that that in the distant future, long after every star has burned out and every planet has gone cold, black holes will represent nearly the last remaining structures in the universe, slowly leaking away their mass as faint radiation into an otherwise empty cosmos, until eventually even they finish evaporating completely, leaving nothing behind but the faint, spread-out radiation of everything that ever existed. Number 3. Physicists studying the mathematics of an eternal, decaying universe discovered a deeply unsettling side effect: that in an infinite or near-infinite span of time, the overwhelming majority of conscious minds that will ever exist will not be real, evolved beings, but random fluctuations of consciousness assembling briefly out of chaos. This concept, called the Boltzmann brain problem, is based on statistical work developed from physicist Ludwig Boltzmann's 19th-century thermodynamics, and was formally analyzed by physicist Andreas Albrecht and Lorenzo Sorbo in a 2004 paper published in Physical Review D, examining what happens to probability in an extremely long-lived, high-entropy universe. In an old, nearly empty, high-entropy cosmos, given enough time, random quantum fluctuations will eventually assemble absolutely anything that is physically possible, including a fully formed, momentarily self-aware brain, complete with false memories of an entire lifetime that never actually happened, a mathematically far more probable event than an entire evolved biological civilization arising through billions of years of ordered development. Physicist Don Page at the University of Alberta has argued extensively since 2006 that this problem represents a genuine crisis for cosmological models predicting an eternal or extremely long-lived universe, because it suggests that any given conscious observer within such a universe is statistically far more likely to be a fleeting, isolated hallucination than a real being with an actual past, a conclusion that remains formally unresolved. Number 2. Physicists have calculated that long before the universe grows physically cold and dark, the accelerating expansion of space will have already erased nearly every piece of evidence that anything beyond our own galaxy ever existed, permanently and irreversibly deleting the observable proof of the Big Bang itself. Physicists Lawrence Krauss and Robert Scherer published a paper in 2007 in the journal General Relativity and Gravitation, titled The Return of a Static Universe and the End of Cosmology, demonstrating that the accelerating expansion confirmed by the 1998 supernova observations is steadily pushing distant galaxies beyond our observable horizon permanently, faster than their light could ever reach us again. Krauss and Scherer calculated that in roughly 100 billion years, every galaxy outside our own local group will have been carried away by cosmic expansion faster than light can bridge the growing distance. And the cosmic microwave background, the primary evidence confirming the Big Bang occurred at all, will have stretched and faded into complete undetectability by any instrument. Any civilization existing that far into the future, looking up at their sky, would see only their own isolated galaxy, surrounded by absolute empty blackness, with no observational evidence whatsoever that a Big Bang, an expanding universe, or any other galaxy had ever existed at all, a slow, silent erasure of cosmic history, occurring long before any star actually goes dark. Number 1. Some physicists have proposed that none of these endings are actually final at all, and that the true fate of the universe is not a single, permanent conclusion, but an endlessly repeating cycle of destruction and rebirth, meaning everything discussed throughout this video may have already happened, and may already be destined to happen again. Physicist Paul Steinhardt at Princeton and Neil Turok at the Perimeter Institute developed the Cyclic Universe model beginning in 2002, proposing that our universe periodically undergoes a big crunch-like collapse, followed immediately by a new Big Bang-like expansion, driven by the collision of higher dimensional membranes described in string theory, repeating the entire process indefinitely across trillions of years. Separately, Nobel laureate Roger Penrose proposed conformal cyclic cosmology in his 2010 book Cycles of Time, arguing that the extremely distant future of one universe, cold, dark, and populated only by evaporating black holes, becomes mathematically identical to the extremely hot, dense beginning of the next universe, allowing information to pass seamlessly from one cosmic cycle into another without ever truly ending. Neither model has achieved scientific consensus, and both remain actively debated within theoretical physics, but if either is correct, it fundamentally changes the meaning of everything else on this list: heat death, vacuum decay, the Big Rip, proton decay, and the evaporation of black holes would not represent a true final ending at all, but simply the final chapter of a story the universe has already told before, and is already quietly preparing to tell again. If you want to see more videos like this, click the video on screen now, and make sure to subscribe.